Hello students, we are solving problems on balancing. Okay, we'll just continue with the problems. So, four masses M1, M2, M3 and M4 which are 100 Newton, 150 Newton, 120 Newton and 130 Newton respectively. Okay, so there are four masses M1, okay, M2, M3 and M4, four masses, okay, which are revolving at an angle of 60 degree. First will be 0 degree, 60 degree, 135 degree and 210 degree from mass 1. From here the angles are taken. Okay, if it is told successive, you need to add the angles. Now it is given from mass 1. See here 60 degree, 135 degree and 210 degree from mass 1. So all are given from mass 1. So directly you can consider these angles. Okay, now we will go on solving the problem. So just write these values. It is given 100 Newton, M2 is 150 Newton, M3 is 120 Newton and M4 is 130 Newton. And the radius are given R1, R2, R3 and R4. So radiuses are given how much? 0.225 meter. If it is given in millimeter, you should divide by 1000 to get it in meter. Okay, then 0.175 meter, 0.25 meter and 0.3 meter. Okay, you need to find what is the balanced mass M for a radius of, it is given of 0.2 meter. Okay, this is given 0.2 meter. Okay, in problem statement it is given 0.2 meter. So now you just find out what is M1 into R1, M1 into R1, M2 into R2, M3 into R3, M4 into R4 and M into R. So just multiply these two values. So you will get 22.5 Newton meter. 150 into 0.175 is, you will get 26.25 Newton meter. M3 R3 will get, so when you multiply, you will get 30 Newton meter. Okay, and when you multiply 130 into 0.3, you will get 39 Newton meter. Now when you multiply M into R, M value you need to find. So M into R will be 0.2 M. Okay, so 0.2 M. Now we will write the theta values. So what is theta 1? So theta 1 is always 0 degree. Theta 2 is 60 degree from here M2. Theta 2 is 60 degree. Theta 3 is 135 degree and theta 4 is 210 degree. So these angles are given. Theta 1 is 0 degree, theta 2 is 60, theta 3 is 135 and theta 4 is 210. Now we need to find what is cos of these values. Cos of these values. When you find cos of 0, you will get 1. Cos of 60, you will get 0.5. Cos of theta 3, you will get minus 0.707. Cos of 210 degree is 0.866. Now similarly, you find sine of these values. Sine of theta 1, sine of theta 2, sine of theta 3 and sine of theta 4. Sine of 0 degree will be 0. Sine of 30, that is 60 degree, will be 0.866. Sine of theta 3 will be 0.707. Sine of 210 degree will be minus 0.5. So after getting these values, just substitute in the formulas, that is horizontal force and vertical force. horizontal force is given by delta H is equal to m1 r1 cos theta 1, m2 r2 cos theta 2 plus m3 r3 cos theta 3 and last is m4 r4 cos theta 4. So now what is m1 r1? So already I found out 22.5 into cos theta 1 will be 1 plus m2 r2 is 26.25 into 0.5. m3 r3 is 30 into minus 0.707 plus m4 r4 is 39 into cos theta 4 is 0.866. So when you multiply 22.5 into 1 will be 22.5, 26.25 into 0.5 will be 13.125, minus into plus will be minus, 0.707 into 30 will be 21.21, similarly plus 39 into 0.866 will be 31.2. When you add all these values, we will get delta H value as 45.615 Newton meter. So this is the horizontal component whatever you are getting when you add all these values. Okay, similarly you should find what is vertical component or vertical forces. That is delta V is equal to same m1 r1, instead of cos you take sin, m2 r2 sin theta 2, m3 r3 plus m3 r3 sin theta 3 plus m4 r4 sin theta 4. Now what is m1 r1? You know the value 22.5 into sin theta. Here you have put cos theta, now you put sin theta into 0 plus 26.25 m2 r2 into what is the value of sin theta 2 is 0.866 plus m3 r3 is 30 into what is the value here, 0.866 you are having. Okay, 0.866 0.866. Okay, 30 into 0.707 plus m4 r4 is 39 into minus 0.5. Okay, we will get these values. Okay, after getting these values, okay, just go on multiplying. This will be 0 when you multiply these two values. So 26.25 into 0.866 will get 22.7325. Okay, then plus 30 into 0.70 is 21.21, 39 into minus 0.5 is minus 19.5, and when you add all these values, vertical component you will get 24.4425 Newton meter you will get. This will be the vertical component. So after getting horizontal component and vertical component, you should find what is the resultant. Resultant R is given by square root of delta H square plus delta V square. So what is delta H? Delta H value is 45.615 square plus delta V is nothing but 24.4425 square. Okay. Now what is R? R is also a force. It is an balanced force which is given by M into R. M into R value is nothing but 0.2 meter. Yes, 0.2 meter here we have taken. So M into R will be 0.2 meter. So you just substitute that value. M into R will be 0.2 M. So 45.61 square will be 2080.72 plus, so 24 square will be 597.43. So when you add this value, you will get 22,678.15. You will get. Now you, take the square root. 0.2 m is equal to, when you take square root, you will get 51.750. Okay, now you want mass, so m is equal to 51.750 divided by 0.2. When you just take this here, so it will be divided by, so when you find this value, you will get 258.75 Newton. So this is the balanced mass which is required to balance all these four masses which are revolving, okay, in the same plane. We are having different angles, 60 degree, 135 degree and 210 degree. So we can balance those all the masses with this mass of around 258.75 Newton, or it is equivalent to 259 Newton. Okay, now we will find what is the angle at which this balanced mass is rotating. Okay, for finding out that angle theta is equal to, formula is tan inverse of delta V by delta H. This is the formula we will be using. So now theta is equal to tan inverse of, what is vertical component is 24.4425 divided by 45.615. So when you just divide this value, tan inverse of, so when you divide 24.4425 divided by 45.615, you will get 0.5358. This is the value you will get. Okay, when you take tan inverse of 0.5358, you will get 28.18 degree. Okay, so you will get 28.18 degree is the angle. So that means, so the mass, whatever the mass is, you are getting 258.75 Newton, and angle you are getting 28.18 degree. That means, see, you can balance these four masses, M1, M2, M3 and M4 by only one mass. These four masses revolving in the same plane, okay, at 60 degree, 135 degree and 210 degree can be balanced by only one mass of 258.75 or 259 Newton at an angle of 28.18 degree. So you can take here 28.18 degree by a mass M, which is equal to 258.75 Newton. So you can easily balance these four masses which are revolving in the same plane by a balanced mass M is equal to 258.75 at an angle of 28.18 degree. Okay, so these are the problems we have seen. So that is when the angles are given from mass 1 we have seen, and when the angles are when the angles between successive masses, when the angles are given, we have solved these two types of problems. Okay, so in the next part of lecture we will see all these problems are based on analytical method. So analytical method is nothing but you are using the formulas to solve the problem to find the balanced mass. Okay, so in the next part of our video we will take what is the graphical method, how to find balanced mass, okay, balanced mass and balanced angle, okay, using graphical method. Okay, so now we have drawn all these, whatever the angles okay, we have not drawn as per the scale. We have taken, okay, just for our reference we have taken and we have solved the problem in analytical method. In graphical method you need to draw as per the scale. If it is told 60 degree, so you have to use protractor and draw that 60 degree. If it is told 22 point, okay, whatever the value is, the 22.5, you should draw with the scale and you need to find the angle. So if you solve by analytical method and graphical method, so both the value you should get same. Okay, so in the next part of our video, okay, we'll solve how to take that values, okay, in scale, and how to draw it using graphical method, and to get what is the balanced mass and what is the balanced angle, and we will verify with the analytical method and graphical method. Okay, thank you.